Hello student, I am Prachi. In the last two videos, we see the installations factors involving designing the machine foundation and the requirement for static machine foundations. This is the unit number 6 of maintenance of electrical equipment. And also we see the bearing puller, filler gauge, dial indicator, spirit level. Today we see the measure, earth tester, globular test lamp, multimeters and screwdrivers and all. So we see the type of machine foundation, block type machine foundation, box type, frame type. So this is the filler gauge, dial test indicator, spirit level and the measure. So what is the measure? For measurement of insulation resistance which is very high, a measure is used. Measure consists of a mega ohmmeter and built in generator which is either hand driven or a motor driven. One terminal of the measure is connected to the winding terminal and other is connected to the earth or frame of equipment. In case of fault between winding, both the terminals are connected to separate the winding terminals and the armature of the generator is rotated at constant desired speed. If there is fault between the winding or winding end earth, the pointer will deflect at 0 mark. Otherwise, it measures the insulation resistance in mega ohm. From this value of insulation resistance, equality of insulation is determined. Next is the earth tester. So, a earth tester works on the same principle as a measure. The difference being that slip rings are also provided on the hand-driven generator to permit AC supply to the external circuit through the soil to eliminate electrolytic effect, and a commutator which will rectify the current before it is applied to the moving coil elements. So the next is multimeter. What is multimeter? This type of instrument is a must for a repair shop. It is battery operated instrument and mostly used for determining continuity of the windings. This meter has facility to measure the resistance value. By selecting the suitable range on the dial, almost correct value of resistance can be measured. The meter also provides the facility to measure the current in different range or voltage in different ranges. So multimeter is used for different range of current and voltage to measure. And then the global. This is the diagram of growler. It is a equipment used for finding shorted turns of armature coil or stator or rotor winding. It is essentially a single winding transformer. When connected to single phase AC, it will produce alternating flux. When this link will be with the shorted turns of winding, very large current flows through it, producing a humming turn or causing vibrations. Or hacksaw blade plates on the slot containing the faulty coil. It is available in two forms called as external grower and internal grower, and can be used to find out shorted turns fault in armature winding or rotor and stator winding of induction motor. Means it has two forms, that is the external and the internal growlers. So this is about the growler. And the next is following factors to be considered in designing the machine foundation. The foundation should absorb the vibration created by the machine while operating at its full capacity. Second is the foundation should spread over as much area that will not exceed the intensity of load over the soil more than its safe bearing capacity. Third, the friction resistance between foundation block and the soil should be sufficient to withstand the possible horizontal thrust caused by machine while in operation. Fourth is the foundation block should be spread that the resultant of all the forces should pass within the foundation block. So the next is following are the basic requirements of machine foundation. First is horizontal level, second is rigidity or safe bearing capacity, third is freedom from vibrations or the capacity of vibration, absorption of vibration, and the fourth is types of machine, static or dynamic. And the last is sufficient friction resistance to withstand the possible horizontal thrust. So the following are the effect on misalignment on the performance of machine. Means effect of misalignment on the performance of machine. So the um, direct couple. First is increased load on bearing. Second is increase in vibration. Third is increased noise level. Fourth is increases stress on coupling and shaft. And fifth is final effect of this the bending of shaft damages to bearing and overloading of driving machine causing it failure. Overall performance of machine reduces. And seventh is it reduces the machine's life and causes decrease in motor efficiency. Eighth is misalignment phenomenon is one of main causes for economic loss in industry. So the effect on misalignment on the performance of machine is the indirect couple. This is the direct coupled and this is the indirect couple. So the life of belt, rope, chain and gear is shorted. And second is produces distributed vibration. Third is increased noise level. Fourth is bent shaft. And fifth is worn out bearing. And sixth is final effect of this is early wear and tear of both driven. In MCQs, this question is asked means indirect couple and direct couple misalignment on the performance effect of misalignment on the performance of machine. So it is very important points. And the next is making concrete foundation. The first step is to excavate the ground to the size and depth of the foundation pit. This excavation should be carried well down and the bottom and side should be tightly remained to ensure that the underlying earth, the foundation, and the machine, and that the sides of the foundation pit are firm to resist the drive forces. Second is around the outside edge of the foundation pit, a wooden wood should be placed to shape the plinth. It should be so arranged that it should provide cable trenches and pipes etc. it required. Next is the plinth is usually tapered so that it is larger at the bottom than the top. Supported from the top of the plinth molds are the form for the packets for grouting in the foundation bolts. Or alternatively, the bolts may be placed in position and the concrete allowed to solidify around them. And the next is the best method is to leave holes in the concrete face into which the bolts may then be grounded. So the next point is procedure for leveling and aligning. So, in case of direct drives, the first consideration in lining up is that the motor shaft should be leveled. The motor shaft cannot be made level unless the shaft of the driven machine is previously leveled. It is therefore essential that the driven machine or driven shaft is leveled first. The essential requirement in the case is that the shaft must be in line. In case of belt or gear drives, they must be parallel. So, the procedure to be followed in alignment to shaft in direct couple drive. This is the procedure. This is the diagrams of driven shaft to the center of the motor shaft and the direct coupled drive. What is the direct coupled drive? In case of direct coupled drive, also the two shafts must be in line. If the driven shaft is first being leveled, the method will be to bring the two coupling close together and roughly line them up by eye. If the driven machine's coupling is lower, either we have to lift it or cut down the top of concrete foundation to lower the motor. If instead the motor shaft is lower, it can be raised by placing packing and the two coupling are brought in line. The final result is that the two shafts are on the same center as shown in figure. Then the lining up bed drive. And the next point is location of transformer. This is the important point. So indoor sites. The most important thing to be ensured with a transformer installed indoor is proper ventilation, then free movement of air around all the four sides. The level of the transformer base should be higher than the highest flood and storm water level of that area. Next is the transformer should be kept well away from the wall. The minimum recommended spacing between the walls of the transformer periphery from the point of proper ventilation have been shown in figure. So this is also the foundation of transformer and the equipments used for lightening heavy electrical machine. So first is stationary crane for lightening heavy equipment. Second is overhead or gantry cranes for lifting and moving heavy equipment. And third is mobile cranes for lifting and moving heavy equipment on site. Fourth is trunk mounted crane for lifting and moving heavy equipment on site. And fifth is steam crane, sixth is chain pulley, seventh is chain hoist, eighth is electrical hoist, ninth is screw jacks, tenth is winches, 11th is houses and tripods, 12th is ceiling ropes for lifting heavy equipment. And these are the types of machine foundation. For wall type machine foundation, see the image in the first lecture. I will also explain it, but see these images: box type machine foundation, and the difference between these four means block type machine foundation, box type, frame type, and the wall type. So this is the images of type of machine foundation. So today's thank you.